Hey guys, I've always enjoyed working with live loads, so I built a loader in 2015 and an unloader in 2022. In case you're wondering why it took 7 years to build the unloader, my twin boys came home in 2015, so life has been largely about kids for the last while. But I'm gradually getting more time to myself and my layout is starting to move again. I've managed to lay track and points around the yard where all the action takes place, and I've done some temporary wiring to get some of the yard to operate. There's still much to be done on the yard, but at least I can start moving live loads around. But the yard is still very much in an early state of construction. While I love operating with live loads, I have no appetite for running live loads on my main lines. The thought of vacuuming up a bunch of coal from my scenic areas does not excite me. My track work is good and derailments are rare on my layout, but every now and again something happens and I get a derailment, sometimes because of user error. Also, live loads are heavier than dead loads, so this will increase the risk of wagons getting pulled over on tight bends if something goes wrong. Murphy does seem to have a permanent home in my layout room. But all this fear-mongering doesn't mean that I can't enjoy working with live loads. I just prefer to do it in a more controlled environment, like a yard. I have the Walther's steel blast furnace. Well, technically on my layout it's a manganese blast furnace, based on the area I'm trying to model. But anyway, this furnace needs manganese. It's nice because manganese ore is also black, so model coal works perfectly. The flood loader loads manganese into the wagons that can feed the furnace. If you are modeling a steel furnace, which most people do, you will replace my manganese with iron ore and everything has an orangey brown look rather than my blackened look. The yard has an old British class 08 shunter that does all the work in the yard. I modelled South African railways in the late 70s and early 80s, but for some reason I just love the British class 08 shunter, so this privately owned yard is a good place to have it. It's a Hornby fitted with a sound decoder and very importantly a keep alive capacitor. I generally run it without the sound so that the keep alive has all its energy to keep the wheels turning if it loses power. It's just more forgiving at very slow speed running if the track is a little dirty, even with such a short wheelbase. The track work is good, but with something this short and travelling very slowly, I prefer to have all my bases covered. I hate stalled locos. I digress, so back to the live loads. I've modified an SAR B2 wagon so that it can receive and discharge live loads. I'll explain why I chose this wagon later in this video. To start the process, the shunter pushes the empty wagon into the spur that contains the loader. I have a control panel that I'll show later in the video, where I tell the loader how many wagons it must load and what type of wagons they are. The loader is controlled by an Arduino that controls the height of the flood loader chute and how much manganese to release into the chute. Once I've told the loader what's coming, I press a ready button and the signal on the outcoming side of the loader goes from green to red. This shows that the loader is ready and traffic can only travel out of the spur through the loader. Once the loader is ready to load, the incoming red signal changes to green and the loco can pass through the loader. At the correct time, the loader chute is lowered to the correct depth and manganese is discharged. The manganese stops flowing just before the end of the wagon. As the end of the wagon reaches the chute, it automatically lifts up out of the way. The Arduino knows what's happening down on the track below using two lasers. You can see the red lasers shining on the loco as it moves through the loader. The two lasers shine onto two LDRs which are hidden in an electricity box and a fire extinguisher reel. From the front you see the two red lasers shining through the wall, but the LDRs are hidden. The sudden jerky movements of the chute are not that prototypical, so once I program the decoder in my class 08 shunter, I should be able to slow it down to more prototypical speeds, and then I'll slow the loader movements as well, as there will be more time to make these movements. The speed table in the loco is the factory default at this stage, so speed step 1 is still way too fast. The loco then makes its way to the raised track behind the blast furnace to unload the manganese. The loco pushes the wagon up the raised track to the unloading area behind the blast furnace and slowly pushes the wagon over the unloading area. The manganese is automatically discharged from the wagon. Here it is seen from a different angle. I have allowed for 2 wagons to discharge manganese at the same time, but I've only converted 1 wagon at this stage. I'll do a second wagon once this video is done. Once the loading is complete, the loco pulls the empty wagons away and the process can repeat itself. Or the loco can do other useful things in the yard like emptying slag or shunting wagons around. So building a loader for only one type of wagon is a little dull, so I set up the loader to load different size wagons because I thought it would be a cool challenge. I seem to like making life difficult for myself. I later discovered that some coal flood loaders in South Africa actually do cater for different size wagons, so this is actually prototypical if I was working with coal. But hey, uniformity is less of a challenge. So that was loading a single wagon. Here is loading a variable consist. The consist is made up of DZ, B2 and CR wagons, each with different heights and different capacities. The loading process starts with entering the consist into the loader control panel. You have to do this every time you load, even if it's just one wagon. By default it shows the loco on the LCD. I have programmed 3 types of wagons into the loader, the DZ wagon, the CR wagon and the B2 wagon. I tell the Arduino the order of the consist by pressing the right button to move from the loco to the first wagon. It's a DZ wagon, so I scroll through the 3 wagon types until I get to the DZ wagon. I then move on to wagon 2, which is a CR wagon. Wagon 3 is a DZ, wagon 4 is a B2, wagon 5 is a DZ. The 6th wagon doesn't exist, so the Arduino knows that's the end of the consists. When I'm happy with the programming, I press the ready button and the signal on the loader changes from red to green and I can start loading. So that's the end of the demo, but I'll spend the rest of the video showing a few behind the scenes shots of how all this works for anyone who's interested. I'll do the loader first, and then the wagon, and then the unloader. The loader has 2 bins, the larger fixed storage bin to hold all the manganese, and the smaller moving bin. The moving bin is attached to the flood loading chute. The reason for the moving bin is that the measured amount of manganese for a particular wagon is rapidly discharged into the moving bin, which temporarily stores the manganese while it is being loaded into the wagon. The chute being drowned by the manganese in the wagon controls the rate at which manganese is discharged from the moving bin. The moving bin position is controlled by a servo motor. This allows repeatable and accurate positioning of the chute. You don't want to have the chute snagging or crashing into wagons or your loco. The key behind the moving bin is that even if the loco stops halfway through the loading process, the correct amount of manganese has already been measured and discharged into it. So what happens down below in terms of stoppages makes no difference to the amount of manganese that will be loaded. If there was no moving bin, the timing of the release of material would need to account for any stoppages. Again, the keep alive capacitor in the shunter should iron out any connectivity wrinkles if they occur, but stuff happens. It's also a bit harder to clean the track under the loader, so things might go pear-shaped every now and again. When this happens, I don't want unnecessary spillages or short loads. If you can design out potential reliability issues, then why not do it? The actual measuring happens by another type of flood loading. A servo motor lowers and lifts a plunger. When the plunger is down, the manganese flows freely from the fixed bin into the moving bin. When the plunger is lifted, it floods the mouth of the fixed bin and the manganese stops flowing. The Arduino code lets the servo know how many milliseconds the plunger must be down for. Each wagon type has a defined time for the plunger to be open, which translates to a volume. There's a pretty good relationship between time and volume, so this allows for a fairly high level of accuracy and repeatability. The flooding plunger is key to cutting off the flow. A guillotine type arrangement, where something moves into the chute horizontally to cut off the flow, always runs the risk of getting snagged or jammed on a stray piece of debris, and then will either not open or close properly. The plunger operates in a free-flowing environment below the fixed bin chute, so there is nothing to jam it, apart from too much manganese in the fixed bin chute mouth when the plunger closes. Whether this happens or not, the manganese still stops flowing, which is the desired outcome. The plunger shaft is fully sleeved, so no debris can block it. Through experience, I learned that the plunger servo might not be able to raise the plunger to the fully closed position every time. This is because the plunger causes the fixed bin chute to flood, and this is a variable condition. This created havoc with the servo, so I installed a spring to allow some flexibility in the up movement of the plunger. The servo will just do what it is told, and the plunger will react to whatever is happening in the mouth of the fixed bin chute, with the spring taking up any anomalies. This works really well. I used an old CD player for the rail that the moving bin moves up and down on. This is why the behind the scenes workings look a little shabby, but it was free, it moves well, and it has been put together by a robot, so that it has far better tolerances than anything that I would put together by hand. It is hidden behind all the loader cladding, so its looks are actually irrelevant. Its performance is all that's important, and its performance is perfect. It's never once given a hint of troubles. I have footage of all the detailed step-by-step processes, and one day I might spend the hours and put together a detailed how-to video if people want one. But with time in short supply and other stuff needing to be figured out and built and tested, this will likely be a retirement project when I have more time. I also think those that are inclined to build something like this don't need that level of detail once they have the concept in their heads, but I could be wrong. The comments, as normal, will tell. So that's the loader behind the scenes. The wagon is far simpler. The wagon needed to have a mechanism that could be opened and closed remotely. I investigated doors and springs, and all seemed a little too fiddly for my abilities, and I was worried about reliability. I eventually settled on a gravity system that is open magnetically. I bought round neodymium magnets and put them in a piece of styrene tube. Then I glued 3 magnets together, poles the same way, to create the lifting force needed to lift the styrene tube. Through trial and error, I determined that 3 magnets would have the right amount of force to lift the tube up through the weight of the load above it. You need enough force to push the styrene tube through the load above it, but not too much force that it lifts the styrene tube right out of the wagon when it is empty. I initially used a lovely plastic coal. I love the stuff. It looks phenomenal and it flows well, but it was too heavy. The magnetic force needed to lift the styrene tube when the wagon was full was too high. This created havoc when the wagon was empty, so I had to resort to using the Woodland Scenics Mine Run coal. This product is very light, so it works well, but some of it sticks to the magnets, which means that I have to clean the styrene tube off every now and again, otherwise the wagon leaks. It's also a bit powdery, and it blackens everything it touches, and doesn't look that great, so I will be looking for a better product in the long run, if one exists. When selecting the wagon, I had to get the wagon height right. If the wagon is too flat, the inner wagon lining will not be steep enough for the manganese to flow. If the wagon is too deep, then the magnets won't be strong enough to lift the styrene through the load. I used black styrene to make the wagon liner so that I didn't have to paint it. I hate painting stuff. It's not my happy place. The liner is shaped so that the manganese will flow out of it. I made a hole across most of the length of the wagon so that the manganese will flow easily out of the wagon. The cross beam above the bogies was filed to a sharp point so that minimal or no manganese can get trapped there and fall off somewhere else on the layout. Because of all the magnets being used, plastic wheels are required, else the wagon does its own dance on the unloader and it looks terrible. So that's the wagon. The unloader is also simple, although I did go down a few rabbit holes along the way. I cut away the sleepers above the loader so that nothing can impede the flow of manganese. I then installed a bin system underneath to collect the discharge load and transfer it to a container under the layout for reuse. I have plans for a conveyor system eventually, but for now it will be a manual system while I figure out the conveyors. I've solved horizontal conveyors and conveyors with a mild slope. That's easy. You just rotate a long spring and a tube with at least 2 mm of play between the spring and tube diameters. Then you hide the tube in some cladding. Here is a short one at the base of my tippler. In my trials I've done over 600 mm, which is about 2 feet, long conveyors with no degradation in performance. Custom-made springs are fairly easy to come by from what I've seen. But I'm still figuring out steep slope conveyors, as the spring method fails miserably at more than about 30 degrees. On my layout, space is limited, so my conveyor will generally need to be closer to 45 degrees. I have a bunch of ideas that are in various stages of model trials, from vertical loaders to Archimedes screws of various forms. Some show promise, others look rather dodge. I've ruled out compressed air systems, there's too much noise and moisture, but I haven't had the time to get any of these trials into finality at this stage. If any of you have solved this problem, please share your method in the comments. I'd welcome a short circuit to this solution. Back to the unloader. I glue the magnets between the sleepers, and when you push the wagon over the magnets, they repel each other, and the styrene tube lifts up to release the load. Once the wagon is off the magnets, the weight of the magnets in the styrene tube is enough to hold the tube in place and prevent any leakage. I had to put a pin and 2 wires to keep the styrene tube movements within a fairly tight tolerance, because when the wagon is empty and the magnets are not aligned above each other, the styrene tube gets pushed longitudinally, sometimes onto the bulkhead. I mentioned rabbit holes earlier. I did originally build a system to raise and lower the magnets, but decided against using it. The problem with this type of system is that the wagon's placement must be very precise to get effective unloading. Another bigger concern for me is that the push rods must be sleeved in a space full of falling bits of debris. Who knows when something will bounce off something in a direction that is not expected and jam a push rod. A guy much cleverer than me once said, "The best part is no part," and I figured fixed magnets would be more reliable. I could be wrong, but that's the decision I've made and I'm sticking to it for now. Thanks for watching. I hope that it won't be another 7 years before my next idea comes to fruition. I'm trying hard, but family is the most important thing. I hope that this video will inspire some additional ideas, or those that have already done some really cool stuff into making videos on working with live loads, and I look forward to seeing other better ideas so that I can improve my stuff. Take care.